Hello students, welcome to your Chapter 8 review video. In this video I'm just going to briefly go over the things that we might be seeing on our Chapter 8 test. I'll show you a couple of examples and just help you sort of review the things that I'm expecting we have started to learn and master here in Chapter 8. So Chapter 8 started all the way back with talking about polynomials and talking about adding polynomials and the standard form of polynomials and things like that. So an example from that first section would be something like if I have 3x squared plus 4x plus 2x to the fourth, and then that polynomial is, well, if we minus from that, let's say 2x minus x squared. Okay, so let's say we're asked to subtract these polynomials. We simply just look for the like terms in our two polynomials that we are subtracting. So in this first polynomial, I notice there's a 4x here in the middle, and the first term of the one I'm subtracting is 2x. So I can do 4x minus 2x. 4x minus 2x is going to leave me with 2x. Okay, so I know that that term is going to be in my answer polynomial. I also notice that I have an x squared piece in the polynomial I'm subtracting here. And I notice I have 3x squareds in the first polynomial. So what I can do is I do 3x squared, and then remember that I'm minusing a negative x squared, right? I'm doing 3x squared minus a negative x squared. Minusing a negative is like adding one. So it actually, instead of 3x squared, now it becomes 4x squared because I am, again, minusing a negative, okay? And then there is nothing to be done with the 2x to the fourth because there's no other terms in that second polynomial to subtract from 2x to the fourth, so that just stays exactly the way it is. Okay, so we can have this answer, but when we talked at the beginning of this chapter about polynomials, we talked about always putting our answers in standard form, which means no like terms that we can combine, and the degree of the terms has to go down, right, from biggest to smallest as we look at the polynomial. So remember that the degree of each term is simply the total number of variables on that term, right? So for example, if we have a term that looks something like this, like 5x squared z to the seventh, the degree of this would be 9 because it's 2 and 7 put together. The total number of variables, I have 2 x's multiplied and 7 z's. So in this particular example, we don't have to worry about that because all we have is x variables, but we do need to sort of rearrange and put this 2x to the fourth at the beginning of the polynomial because it's the highest degree, right? It's the highest exponent. So to put our answer in standard form, we would move the 2x to the fourth to the front, plus 4x squared because that's positive, plus 2x, and there you have it. Okay, so that would be the standard form answer when we subtract these two polynomials. And the degree of this polynomial here would be 4. Okay, it's degree 4 because that is the biggest degree of any of these three terms, 1, 2, 3 terms. It's degree 4, okay? So remember that we did have a special name for fourth degree polynomials, right? We called those quartic, like quarters, quartic. Okay, and there are 3 terms here, and we had a special name for polynomials with 3 terms. We called those trinomials. So our answer here is a quartic trinomial. Okay, so we may have to classify polynomials on our test. We may have to give the degree of a polynomial, looking again at the biggest degree of any of its individual terms. We may have to rewrite polynomials into standard form, and so on. So that's basically all of section 8.1 is an introduction to polynomials, adding and subtracting polynomials, standard form, classification, and all that good stuff. Okay, so that's section 8.1. Section 8.2 then was more about the distributive property. Okay, we were applying the distributive property to the to polynomials. So we were doing things sort of like this. So something like 4x times in parentheses 2x minus 3x to the third plus 4. Okay, and we were taking this and writing it, what we called simplifying it or writing it in standard form. Okay, so no parentheses, no like terms that can be combined, etc. So this is just basically a complicated version of the distributive property where we multiply that term in front of the parentheses by each of the terms in the parentheses. So we start with 4x times 2x. 4x times 2x, 4 times 2 is 8. X times x is x squared. Okay, and then we do 4x times a minus 3x to the third. So again, we multiply our numbers, multiply the numbers together. 4 times negative 3 makes negative 12, so this becomes a minus 12. We have an x multiplied by x to the third, which makes x to the fourth power. Okay, so that's the second piece. And then 4x times a positive 4 simply becomes plus 16 with an x. Okay, so this would be my answer, but again, this is not one that's in standard form right now, right? Because again, this term with the x to the fourth power would need to go first, would need to be in the front. So what I do is I take the whole thing, the whole minus 12x to the fourth, I move that to the front. The next term is a positive 8, so I put a plus 8x squared, and then at the end it's plus 16x. Okay, so this right here would be the standard form answer when we distribute 4x into each of these pieces. And so we had to do that. We also then looked at going the other direction, right? We looked at going from a polynomial to a factored form by taking out a greatest common factor. So something like this. If I had 3x to the third plus 6x squared plus 12x, and I wanted to factor out the greatest common factor here, I would notice first that each of these three numbers can all be divided by 3. So I'll factor out the 3 first and put that in front of a set of parentheses. But I'll also notice that each of these terms also has a variable x. So I can at least factor out an x. Now, if they all had some sort of exponent on them, I could factor out more than one x variable. But because the last term here just has 12x and it's just an x, not x to the second or x to the fifth or anything like that, all I can factor out is just x, right? We think about this as like x to the first, so the smallest exponent is 1 on my x variables here, so that's what I can factor out. And then what I do after I have decided what the greatest common factor is or what the common terms are that I can factor out is I'll write in the parentheses what's left when I divide away that common factor, okay? So I divide each of the numbers by 3. This number is a 1. 3 divided by 3 is 1. 6 divided by 3 is 2. 12 divided by 3 is 4. And then I divide away one x from each term. So x to the third now becomes x squared. X to the second now becomes x to the first power, which I don't need to write there. And then the last term, x to the first, now all the x's are gone because I factored out the only x that was there. And so I end up here with this factored form when I factor out that greatest common factor. Okay, so multiplying something into a polynomial in a set of parentheses with the distributive property, factoring out a greatest common factor, undoing that process, that is section 8.2. Section 8.3 is where we started doing the FOIL method, also known as the double distributive property. Okay, that was where we were taking two sets of parentheses and multiplying them together, something like this times this, right? Where we have two binomials and we multiply them together by multiplying the x to both of the pieces in the other set of parentheses. I get x squared minus 5x, and then multiply the 3 to both of these pieces. and I get plus 3x minus 15. Okay, so this is my polynomial. It's almost in standard form. I just have to combine these two middle pieces. A negative 5x plus 3x makes negative 2x. So I end up with this. Okay, so I write this polynomial in standard form. Came from multiplying these two binomials together using that FOIL method, right? First, outside, inside, last, or double distributive property. They can get more complicated. We can look at an example that says maybe 3x squared minus 2 times 4x plus 3. Okay, so now when we multiply, we just have a little bit more complicated stuff to be dealing with here. I still do this piece distributed to both of the other pieces. 3x squared multiplied by 4x. 3 times 4 is 12. X squared times x makes x to the third, right? So that's the first term. 3x squared times 4x gives me this, 12x to the third. 3x squared times 3 gives me just 9x squared. Okay, and then that's the second term. Now I take the second piece of the first parentheses, which is negative, by the way, right? It's a minus 2, so it's negative 2. And I multiply it by each of those two pieces. Negative 2 times the 4x makes minus 8x. Negative 2 times the 3 makes minus 6. Okay, so this is my polynomial. There's nothing for me to combine here because all my variable pieces are different, x to the third, x squared, x, no x's. So that's my final answer in standard form right there. Okay, so FOIL method or double distributive property can look more complicated. We did also look at some examples that were slightly easier. Okay, we looked at our last example from section 8.3. This was actually section 8.4, multiplying special cases, we called it. We can do things like this, t plus 4 times t minus 4. Okay, remember what happens when we multiply two sets of parentheses that are exactly the same except for the sign in between. When we multiply the t times that, we get t squared. When we multiply the t times that, we get minus 4t. When we multiply the plus 4 times that, we get plus 4t. And then plus 4 times minus 4 makes minus 16. Okay, so this is our regular FOIL method, but notice what happens here, right? A negative 4t plus 4t is actually gone, and so I'm just left with t squared minus 16. Okay, t squared minus 16. So when you have the same thing in the set of parentheses, it can come out like this. And the only other thing that we were asked to do in section 8.4 was to take something like this, let's say 2x plus 1, and square it. Okay, so remember, we just turned this back into a regular FOIL method looking problem by recognizing that 2x plus 1 squared is simply 2x plus 1 times another 2x plus 1. Okay, and then we did regular FOIL method, right? Move that over there, right? Okay, so remember when you see a binomial squared, you just write it separately. You don't just square each of the pieces inside. We have to do the full FOIL method or double distributive property for those as well. Okay, that was everything that we talked about before we took our chapter 8 quiz up through sections 8.4. Okay, then after our quiz in section 8.5, we started going backwards. We started looking at quadratic trinomials that look something like this. And we talked about factoring these quadratic trinomials into their binomial factors. Okay, so when we factor, our final answer should always end up looking something like this, like two sets of parentheses being multiplied by each other, possibly with a number in front, right? We looked at that right at the end of the chapter. Maybe there's something there, but factored out with parentheses is what we're looking for here. When we're asked to factor ones where there was no number in front of the x squared, remember that that was simply asking what two numbers multiply to make 12 and add together to make 8. In this case, numbers that multiply to make 12 and add to make 8 would be positive 6 and positive 2. Okay, so this would be the factored form of that particular trinomial. So when we didn't have a number in front of x squared, this process was a little bit easier. When we did have a number in front of the x squared, let's say 2x squared plus 11x plus 15, okay, something like this. This is a case where we have to use the window method, right? Assuming that the first and last pieces are not perfect squares, because remember those were our special cases where we could square root the first and last piece, multiply and double and see if it matches the middle. In this case, we can't do that because we don't know the square root of 2 or the square root of 15. So then we do have to do the window method. And just a reminder on the window method, we did this sort of in 2 separate lessons. One was where we filled up our window. So we put these numbers here first. We multiplied them together. 2 times 15 is 30. And then we figured out what 2 numbers multiply to make 30 and add together to make 11. Multiply to make 30, add together to make 11. That would be 6 and 5. Okay, 6x and 5x. And then in our next video, we talked about how do we turn this window into our 2 factors, okay, our 2 binomials. And we did that by going across and finding our greatest common factors, right? So 2x squared and 6x. 2 and 6 can both be divided by 2, and they do both have an x. 5x and 15, they can both be divided by 5, but they don't both have an x. And then going up, we found our other greatest common factors for our other set of parentheses. 2x squared and 5x. 2 and 5 can only both be divided by 1. X squared and x can both be divided by x, right? They both have an x in them. And then 6x and 15, 6 and 15 can both be divided by 3. And they do not both have an x, so I don't get to take an x out of that. So that gives me my 2 factors, 2x plus 5 from right here, and x plus 3 from up here. Okay, so that's just a real quick refresher on the window method. You can always go back and look at the videos on the window method as well. And then the last thing that we did was we talked about the special cases for factoring. Okay, so section 8.7 was a couple of special cases, one of which they all involve perfect square numbers, right? We needed our first and last numbers to be perfect squares. One example was if we had something like this, like 4r squared minus 81. Okay, so this 4 and this 81 are both something squared and they're being minused. Okay, so this was an example. Remember, we called it the difference of 2 squares, and it allowed us to factor very quickly into 1 plus and 1 minus with the same thing. Okay, so the square root of 4 is 2, and that gets my variable r. The square root of 81 is 9, and so my 2 factors end up 2r plus 9, 2r minus 9. Okay, when we have the difference of 2 things that can both be square rooted, we can turn them into our 2 factors, one with a plus sign, one with a minus sign, and the same pieces inside. Okay, and then the other one, we had, let's say, 16m squared minus, and then at the end we'll put a plus 49, and this will be 56m. Okay, so this one looks like a very complicated version of the window method until we realize that we can square root the 16, and the square root of 16 is 4. We can square root the 49, and the square root of 49 is 7. If we multiply those together, we get 28, and if we double 28, we get 56. So then this is an example where we can actually factor into a set of parentheses squared very quickly, because we can do the square root of 16, which is 4, that gets the m. The square root of 49 is the 7, and because this symbol was a minus, this symbol is a minus as well, okay? So those were our two special cases for factoring. You can go back and look at our video on lesson 8.7 if you need to refresh that at all. And then the only other thing we talked about in our sort of extension video was remembering that every time we factor, the very first thing we always look for is a common factor to take out, right? So if I had something like 5x squared plus 15x minus 200, for example. Right? Again, this looks like a complicated version of the window method until we realize that each of these terms, 5, 15, and 200, can all be divided by 5. So I basically go back to what we did in lesson 8.2, where I'm just factoring out that greatest common factor, right? 5 is the greatest common factor here, and then I just have x squared plus 3x minus, that would be what, 40? Okay, so then I have 5 multiplied by this, and then I can go ahead and factor what's in the parentheses as long as I can find, because I don't need the window method anymore, right? There is no number in front of the x squared in the parentheses, which is excellent news for me. As long as I can find two numbers that multiply to make negative 40 and add up to a positive 3, I can factor, right? And those two numbers are positive 8, negative 5. So I factor like this, and then that 5 stays in the front all the time. So that's just a real quick refresher with an example of each different type of problem that we've talked about in Chapter 8. You have all the videos, so go ahead and go back and refresh. Just this should give you sort of a remembrance, I guess, or a refresher on what we covered, what maybe seems the hardest, what is the thing that you need to go back and look at again, okay? If you have any questions about anything in Chapter 8, do please reach out to me before you take your test. I will do my best to explain it in more depth. This was obviously just a quick version of each one. But otherwise, that's all I have for you right now, and we'll talk to you soon.